project that I'm working on is with focused ultrasound to basically treat and ablate biofilms off of catheter-based medical devices. Anytime we put these devices inside the human body, you can grow biofilms on them. Bacteria then can harbor there and cause infection in the body. And so what we want to do is be able to remove and kill those biofilms on those medical devices non-invasively by using ultrasound. We didn't have a whole lot of literature onto whether or not this was actually feasible, and so the first part of my project was really kind of that proof of concept of determining, is this feasible, is it possible, can we get a cavitation cloud or an ultrasound histotripsy cloud inside the lumen of a catheter? Can we remove a biofilm, and can we kill bacteria? Were kind of the three just general big questions that we had at the beginning of the project.
Chris really started this entire project, which was a completely new direction for our lab. So histotripsy, the core technology that our group works on, is a focused ultrasound technology that we're currently developing for a lot of applications, but mostly in oncology, so non-invasive treatment of tumors, liver tumors. We have some work on pancreatic cancer. So Chris came in and was very interested in developing a technology, a version of this that we could actually use for the treatment of biomaterial-associated infections.
What we found in my project was that, one, we could use focused ultrasound to treat the inside of a catheter. We also found that focused ultrasound, when we apply it to these catheters, will remove a biofilm from the catheter. And lastly, we found focused ultrasound will also kill bacteria in suspension. The future of medicine is starting to do things through smaller incisions, through completely, potentially in our case, non-invasive procedures. And if we could do that with this technology, it means the world for the patient, because then they don't have to have a needle stick, they don't have to go under the scalpel or anything. It's just an ultrasound device like you would go and have your baby ultrasound. I originally wanted to go into emergency medicine, but this project exposed me to radiology and interventional radiology, kind of learning about the minimally invasive and non-invasive ablation methods. And from that, I started to become more interested in it, did more research, and now I've just applied to interventional and diagnostic radiology for my residency choice.
I work with a lot of the leading interventional radiologists in the world, and I think Chris is the next in line to take over for that. And he has that same attitude that's not only caring about the patients, but is thinking ahead to what's next and how can we have more non-invasive technologies that can not only improve the outcomes of patients, but the quality of life going through these therapies. He really has that approach.
If this becomes the next technology that we use to make sure that we keep medical devices sterile and keep patients from becoming septic from an implanted medical device, I mean, that's massive.